So good afternoon, all of you. So basically, we are going to discussing here the MCQs in this session. So basically, for the course Automata theory, 7 MCQs for 2 marks, or may possible that draw it directly rather than writing, rather than by hearting. Okay. So the very first question you can see here on your screen, that which of the following is, that is 0 1 star 0 0 in bracket 1 0 star. So that is the Kleene operation they have given. So meaning of 0 1 Kleene, it may containing all the possible substring, which will also contain null string. So if I take this as a null, then null 0 means on the LHS it will be 0, and on the RHS if I take 1 0 and 1 0 Kleene, and the very first substring from that is a null, then again it will be 0 null, means 0. So whenever you will be take the very first string that is a null, then it is going to balance. Let us consider if I take take that 0 1 Kleene as a one time reading, then it will be 0 1 0 1 0, and on the right side again if it is reading for one time, it is a 0 1 0. So this one is true. So whatever the first statement, which is a true. Second one you can see here, 0 plus 1 star 0, 0 plus 1 star 1, 0 plus 1. So what they have did, if you see here 0 plus 1 star, then 0, then 0 plus 1 star, then 1, and 0 plus 1. So rather than all this writing, they have mentioned here 0 plus 1 star, this 0 plus 1 star, 0 1, and 0 1 star. Again it is a true. And finally, whenever you are talking about third one, 0 plus 1 star 0 1 in bracket 0 plus 1 star plus 1 star 0 star, directly you can return this as a LHS also. Okay, so all these three options, that is A, B, and C, all these are same. So you can give the answer this as a which of the following is true. All of the above, all are the above which are given as a true. Now the next one is a language is a regular if and only if. So when the given language is said to be regular, so as per the Chomsky hierarchy, you know that there are 4 types of the language. That is the regular language, that is a type 3, which is accepted by finite state automata. Then context free language, which is accepted by push down automata. Then context sensitive language, which is accepted by linear bounded automata or Turing machine with the halting acceptance. And the very last one, that is unrestricted language or type 0 language, which is accepted by Turing machine. So our question is what? A language is regular if and only if it is accepted by, which is accepted by DFA. So that is the correct answer, which is accepted by. Okay. So a language is regular if and only if, which is accepted by DFA. Then next question, which of the following is not a regular expression? So we have to find out the regular expression. If you see here, the first example, that is 1 plus B Kleene minus A plus B Kleene minus AA plus BB whole bracket Kleene operation is there. Then in the second one, 0 plus 1, then 0B, A1, AB, and all these combinations are there. In the third one, they are using alphabets as a 0 1 for the writing regular expression. And in the last one, 1, 2, and 0 are used for writing. But if you see in the second one, B, so the B which containing 0 as well as 1, also they have given the alphabets AB. So this one is a not regular expression. Okay, fine. Now the next question, that is a question number 4. Regular expressions are. So regular expression which is related to the regular language and which is related to the finite state automata. And as they have mentioned, type 3 language. Yes, type 3, and which is the subset of type 0, type 1, and type 2. So type 0 is nothing but the superset of all these languages, and type 3 is the subset of all these languages. So regular expression are type 3 language. Now the next one, regular expression are closed under. So we have already seen this question, that is union, intersection, and clean star. So all of them mention that is a regular expression is closed under union as well as intersection and clean star. Now see here, which of the following is same as given DFA? So we have to find out the regular expression for this DFA. If you see here, 4 states are there, Q0, that is the initial state, then Q1, Q2, and Q3. So if you see here, starting from this Q0, Q0 having 0 transition goes to the Q1, 1 transition to the itself, likewise 0 transition to Q2, 1 transition to Q0, and likewise. So if you see here, basically if you see here, this 0, this 0, this 0, 0, and 1, these are must strings. So you can see here 0, 0, 1. So basically 0, 0, 1 is present or in A and B. So may probably option will be from A or B. There is a no scope for C option. So we have to check whether the A is correct or B is correct. Now if you see here, here is what 1 is there and 1 having loop at the starting, and here again if you go ahead, then it having, after reading 0, it is coming back to Q0 with 1. Again in case of this Q2 having 0 to the back, means here will be a loop. So this loop, this one again reading 1, this one and this one will be this 1 star, and this 0 and 0 will be this 0. So 0 plus 1 star, then 0, 0, 1, and finally as we have here 0, 1, so it will be denoted as 0 plus 1 star. So that is the correct answer, first one. One message is there from one student. But all of you are not able to see the screen. Now check. Wait. I'm looking for that, Brunali. Now tell me whether it is visible or not. Now tell me whether the screen which is shared by me is visible to you or not, Mronali. Okay, fine. So this question bank is visible to you? Okay, fine, no issue. So you may go through these questions previously we have discussed. Now see the question number 7. Which of the following statement is not true? So the very first statement is every language defined by any of the automata is also defined by regular expression. Yes, that is correct one. Every language defined by the regular expression can be represented using DFA. Then every language defined by a regular expression can be represented using NFA with a epsilon moves, and regular expression is just another representation of automata definition. So first one and last one definitely both are correct. Now we have to discuss between B and C, or we have to decide in between B and C. So what is the B? Every language defined by a regular expression can be represented using DFA. So it is not possible, because generally what will be happen, sometimes the regular expression whichever given to you, that has to be used the null statement. You can see every regular or every language defined by regular expression can be represented using NFA with the epsilon movements. That is the Kleene theorem 1. You might be remember that. So you can mention here option number 2, that is the wrong one, which is not correct. Now see the total number of states required to automate the given regular expression. So how many states will be required to automate 0, 0 star and 1, 1 star? So if you see here 0, 0 star, 1 1 star. So basically in the case of 0 0 star, it will require to need 0 0 star for 1, 1 1 0 for twice. Okay, so that is the first reading. Then 0 concatenate 0, for that it will require one reading. For 1 concatenate 1, another reading. So that will happen 4 readings. And finally 0 0 star and 1 1 star, concatenation of that, it will be require one more reading. So it will require 5 states will be required. Total number of 5 states will be required. I hope that you will be get this idea. Reading these 0 states will be required. Total number of 5 states will be required. I hope that you will be get this idea. Reading these 0 0 together, 1 1 together, that is the 2 states. Then 0 0 star 3 state. One regular expression corresponding to the given problem statement, P of x express the identifiers in C programming language. So generally in the C programming language, you can see here letters are there, underscores are there, letters, digits, and underscores. So that is the C is the correct answer. Already this question, which is from the conversion of regular expression to the regular language. So keep in mind this one. Then next one, generate a regular expression for the given language, L of x, x I 0, 1 star, x ends with a 1 and does not contain a substring 0, 0, 1. Okay, so what they have given here, the language which is given, x ends with 1. So you have to check wherever it ends with 1 and does not containing a substring 0, 1. So if you see here, in the example number A, B, they are, in the example number A, 0 plus 0, 1 star. So if you're reading for null time, it will not be having end with 1. So it is not correct. Then in the case of B, it will be end with 1 and does not containing a substring 0, 1. But what will be happen? 0, 1 will be substring for single reading of 0 plus 0, 1 star. Then next 0 plus 0, 1 star, 1 plus 0, 1. So that is the correct answer, because 1 plus 0, 1, that is the dynamic term. So definitely it will containing 0, 1 as a end with 1, that is the 1, and not containing the substring 0, 1. So the C is the correct. If L1 and L2 are the regular languages, which among the following is the exception? So L1 union L2, sorry, which one is the expectation? Yes, we can perform union operation, we can perform say difference operation, we can perform the intersection operation. So all these three possibilities are allowed here in the regular language. Now DFA, the question number 12, deterministic finite state automata, transition function maps, that is already we have discussed, Q into summation tends to Q, as they have given deterministic finite state automata. That is a Q into summation. Q means what? It is a finite set of states. Summation is a set of alphabets, and which will be goes to the another state. Then next one, you can see question number 13. Number of states required to accept the string end with 1 0. So as it containing end with 1 0, so for representing 1 0, it must require 3 states. That is, initial state will be there. Then by reading 1, it will be goes to the second state, and by reading 0, it will be goes to the final states. Means in between that 1, 2, and 3, 1 0 will be read. So it will require 3 states. Let us consider if the string ends with 1 1 0, means if containing 3 alphabets, then it must be require 4 states. Keep in mind this. Now the next question, question number 14, which is related to the extended transition function. You can see here delta star, which is nothing but the extended transition function. Delta star of q comma y a is equivalent to. So as per the definition of extended transition function, this is simply written as delta star of q y. Means state will be there. You will be read the first alphabet from the string y a. Then whatever the result of this delta star y delta star qy, that state will be there. Then finally delta of that state comma a will be read, that will be equivalent to delta star of qy, that is the extended transition function. Now the question number 15, number of final state required to accept phi in the minimal final state automata. So what they have mentioned, number of final state required to accept phi in minimal finite automata. So if you want to accept phi, basically it will be require one initial state, and for the accepting, another accepting state will be there. So it will require two states. That is the option number B. Again, the same question is repeated, I think so here. Question number 16. Then question number 17, see here. For the NFA, that is a non-deterministic finite state automata with epsilon transitions or null transitions, which among the following is correct? Means they are asking about the transition function. Already we have discussed this for many more times in the classroom also. So delta should be q into summation union null tends to 2 raised to q. So that is the option correct one. This is the correct option. Already we have discussed during the lectures also. Then next one, the automata which allows transition to the new state without consuming any input symbol. Means let us consider if I want to move from one state to the another state without reading any symbols. So in that case, I'll be go for NFA with the null transitions. So whenever we'll be discussing some problems, I'll be tell you about this NFA with a null transition. But if you want to move from one state to the another state without reading any input symbol, at that time you'll be using here NFA with a null. Then next question, complement of a DFA can be obtained by. So complement, so whenever we are going to find out the complement, so just we are going to interchange the states. Means initial state will become, accepting state will become not accepting state, and non-accepting state will become accepting state. So that is the method. You can see here, making final states or accepting state as a non-final and non-final state as a final state. So that is the complementation. We have seen this example also. A regular language over the alphabet summation is one that cannot be obtained from the basic language using the operation. So a regular language over the alphabet summation is one that cannot be obtained from the basic language using the operation. So all these operations, union, concatenation, and Kleene operations are performed over the regular language. Okay, fine. So you should be keep in mind that all are mentioned should be performed the operation related to the regular language. Just hold for a moment, all of you. Then next question, which of the following is not part of 5 tuples of the finite state automata? So basically 5 tuples, so q summation q naught a delta. So input alphabet, yes, it is the tuple of finite state automata. Then transition function is also tuples of finite state automata. Initial state is also tuples of finite state automata. But the output alphabet, which is not concept in the finite state automata, or which is not a tuple of finite state automata. Yes, so output alphabet, which is not a part of 5 tuples in finite state automata. Keep in mind. Then next one, question number 22. Which of the following is corresponding language to the given D? Very interesting question, this one. So which of the following is corresponding language to the given DFA? So if you see here, this is the epsilon, this is 0, this is 1, and this is n. So if you see here, the very first language n is equals to x belongs to 0, 1 star, x ends in 1 and does not containing substring 0, 1. So as this is a accepting state, x ends in 1 and does not containing the substring as a 0, 1. Yes, it ends in 1. But if you see this null as an initial state, then by reading this 0 and 1, you can see here, by reading this 0 and 1, it ends in accepted state. So the statement which is not going to correct means what? It is ends in 1 directly. No, yes, it is ends in 1, but not contain the substring 01. But on the other side or on the contrary, it ends with 01. The next one, 01 star, x ends in 1. Yes, it is ends in 1, does not contains. Some people are saying that this. And one more thing, 44 candidates are there. I think total 200 candidates for CSE and 56 candidates from data science. So I'm not going to requesting because I am sparing my time for you people. Please convey this message to students, those who are not joined the meeting. And intentionally, I have give the permission for those people who are subscribers. Those people who are subscribers have given the permission to those students because I am spending my time, so they have to subscribe, otherwise they can do their own. Fine. So if those who are difficulties in the what we can say, those who are difficulties in the joining the meeting, they has to be make the they has to subscribe the channel, then and then they can go ahead. Pronali, what is the problem here? Please type message. Now tell me whether it is visible to you. I think previously it was visible. Right now, yes, I'm again sharing the screen. So entire screen. Is it visible now, you, all of you? Now is it, whether it is visible? No. Now tell me whether it is visible to you or not. Now tell me whether this is visible to you or not. Please type the message if it is visible. Yes, it is visible. Yes, okay, fine. So that is the question which we are discussing, the question number 22. So the question number 22, which having second as a correct option. So x which is belongs to 0, 1 star, x ends in 1. You can see here, x ends in 1 and does not contain the substring 0, 0. Yes, absolutely. It does not contain the substring 0, 0 because this 0 and 0 going to the n and accepting state over here. Then option number C, what it says, x ends in 1 and does not containing the substring 0, 0. Ends in 1, what they are given? X ends in 1 and does not contain does not contain substring 0, 0. So what is the basic difference between B and C? So in the case of B, we are going to perform here Kleene operation. You can see here 0, 1 Kleene, and here is only 0, 1. Okay. But if you see, it is going to perform end with 1. Again, it will be reading this 0. Okay. And then it again, by reading 1, it will be going to this position. Okay. So looping is possible over here, so that star must be considered. Now next one, for the machine to surpass all the letters of alphabets excluding vowels, how many numbers of states in a DFA would be required? So 3 states is vowels and consonants. You know that 5 vowels are there. So for surfacing 5 vowels, you have to you will be required 3 states. Keep in this mind. Now next one, what is the regular expression matching 0 or more specific characters? That is a star. You know that. That is the Kleene operation. Matching 0 or more specific characters, you have to use the star operation. The next one, regular expression x plus y denotes the set. What it denotes? It will give here combination xx, then xy will be there, then yx will be there, and yy will be there. So keep in mind this one. The next one, number of tuples in extended non-deterministic finite state automata. So it requires 5 tuples. Whenever you have given finite state automata, non-deterministic finite state automata, and extended non-deterministic finite state automata, and NFA with a null transition, it requires only 5 tuples. Okay, don't be confused about that extra keyword extended. Keep in mind, whenever finite state automata, 5 tuples are there. That is the question number 26. Now see question number 27. What is wrong in the given definition? So they have given one definition. You can see here. Here is the Q. So what is that Q? It containing 3 states, Q0, Q1, Q2. Then they have given alphabets 0, 1. They have given transition function delta. They have given here Q3 as a accepting state, and also they have given Q3 as an initial state. You can see here Q3 as a initial state and Q3, the second Q3, which is in curly braces, that is the accepting state. Okay, so we have to find out the wrong in the given statement. So the definition does not satisfy 5 tuples definition of NFA. No, it containing the 5 tuples. This is the first tuple, second tuple, third tuple, fourth and fifth tuple. These are looking like same, but this first Q3 is the initial state, and this Q3 will act as a accepting state. So this is going to fulfilling. There is a no transition definition. Yes, it having the transition definition because delta is given to you. Then initial and final state do not belong to the graph. Yes, they are having initial and final state. So it is the wrong one. Initial and final state cannot be the same. Initial and final state, definitely they may be same because Q3, yes, they are same. And initial and final state do not belong to the graph. So that is the wrong one. Just hold for 2 minutes. Just hold for 2 minutes. Okay. Fine. Now see the next one. Question number 28. From the given table, delta star of Q0, 0, 1, 1 is equals to delta star of Q0, 0, 1, 1. We have to find out. They have given here some transitions. These are the states Q0, Q1, Q2, and Q3. And here is the delta of Q with respect to 0 and delta of Q with respect to 1. Okay. So Q0s zero transition. You can see here Q0 zero transition goes to itself. Q1 zero transition goes to Q2. Then Q2's zero transition goes to Q3. Q3 zero transition goes to phi. Here Q0's delta star of Q0 0 1 1. So whenever you will be read this extended transition function delta star with respect to Q0 and string 0 1 1, what will be the output? Okay, so delta star of Q0. So Q0 0 1 1. So if you read here Q0 0, so Q0 0 will gives you Q0. Okay, means after reading the first alphabet, it will give you Q0. Then whenever now the control is at Q0. So whenever you will be read 1, so Q0's 1, it will be Q0 Q1. Keep in mind. Now we have the position Q0 comma Q1's 1 transition. Okay, so Q0 comma Q1's 1 transition. So if you see here Q0 comma Q1's 1 transition, it will be Q0 Q1, and Q1's 1 transition will be Q2. So if you see here Q1, that is the option Q1 union Q0 Q1 Q2, because it will be going to combine, that is Q0 Q1 and Q2, and initially this Q0 as well as it Q1 will be present over here. Now 0 plus null, 1 plus null represents what it represents. It will be read 0, it will be read 0 0, and it will be, because it is going to give the combinations. The very first symbol from the first regular expression, that is a 0. Then combination of 0 and 1, yes, that is the third one. Then very first symbol from the second expression, that is a 1, and null will be combined, that is the last one. So that is the correct option, 29. Then next one, a dot is a sequence of statements which are either given a deduction from the previous statements, and those last symbols is conclusion to be proved. So that is the direct proof. It is called as a direct proof. Then next one, there are how many tuples in the finite state machine? 5 tuples, you know that. Minimum number of states DFA required to accept the string end with 1 0. Already this question is over. DFA required to accept the string end with 1 0. Already this question is over. So whenever 2 symbols are there, it will be required 2 plus 1, that is 3 states. Let us consider 3 symbols are there, then it will be required 4 states, and likewise. Then question number 33, you can see here, which of the following is a correct regular expression of language having string start with 0 0? Start with 0 0, yes, that is the correct one, because in the another cases it is not start with 0 0. Second case it is start with either 0 or 1. Third case either 0 or 1, but in the first one it start with the 0 0. Then the next question, which of the following string does not belongs to the language having 0 immediately followed by 1 1? What they have given? Which of the following string does not belongs to the language having 0 immediately followed by 1 1? So if you see here 0, so if you see here this question is little bit wrong one. I'm not confident about this question, but as they have given option C, you go with this 0 0 1 1. 34. Now see the 35. DFA of which of the following language generates an invalid or dead state? Okay, so starting with 0 0, yes, you can draw and calculate here exactly 2 zeros having length 4. So all of these will require dead state. Then next one, how many states need to be formed to design DFA of language containing the substring BB? So BB is there, means 2 symbols are there, it will require 3 states. Which of the following is not accepting null as an input symbol? So NPDA, non-deterministic push-down automata. What they are given? Which of the following is not accepting null as an input symbol. So keep in mind, PDA will not having the null symbols. DFA of which of the following language is having initial state as accepting state? Initial state as a accepting state. DFA of which of the following language is having initial state as a accepting state? So even number of 0, not end with 1 0, maximum length 6, all of these. Yes. So in the very first case, even number of zeros. So even number of 0, that will having initial state and accepting state as a same. Yes, because two states will be there. Initial state, it will be read 0, and by reading 0 again, it will be coming back to the initial state. So that will become the initial as well as accepting state. Then next one is what? Not end with 1 0. So this is a little bit illogical. So the first option, even number of zeros. Keep in mind, this option is correct. Option number 1, this one is the correct one. The next one, which of the following statement is false? Correct. Option number 1, this one is the correct one. The next one, which of the following statement is false? So union of two CFL is also CFL. So that is the false. Keep in mind. Which of the following productions type is in the regular grammar? So A tends to small a capital B, A tends to A. Both are possible, A and B. The minimum number of productions required to produce a language consisting of odd length palindrome string over A, B is. Minimum number of productions required to produce language consisting of odd length palindrome string over A, B is. That is the 5 correct option. Keep in mind this. Which of the following statement is correct? All regular grammar are context free, but not vice versa. Yes, that is correct. Which of the following type of production must not be in CNF? So CNF should not having the null production. In the case of CNF, Chomsky normal form. So basically, in the case of Chomsky normal form, so when the given form is called as the Chomsky normal form, whenever on the LHS there is a non-terminal symbol tends to one terminal symbol, or one terminal symbol tends to the two non-terminal symbols. So both A and B are correct. This is wrong option, whatever highlighted over here. So which of the following type of production must not be. So that is unit production must not be there and null production must not be there. So correct option is C. Correct this one. This option is C. This is the PDF shared by one of your students. So keep in mind both A and B are, that is the correct answer. The next one, A raised to n, B raised to n, where n is greater than or equals to 0 is it is not regular language, definitely. Yes, it is the type of context free language. Already we have discussed context free, or which is a type 2 language. Type 2 language, fine. If a grammar generates more than one derivation tree of at least one string, then the grammar is called as. Okay, so very simple. If grammar generates more than one derivation tree, then it is called as a ambiguous grammar, and that tree is called as a ambiguous tree and ambiguous grammar. So that is the correct option, ambiguous grammar. Then next one, regular expression for the language of word containing substring AA. What they have given? Regular expression for language of word containing substring AA. Yes, here substring may be possible A, but on the right side of that AA there will not be any string, so it is not allowed. Here on the left side there will not be any substring, so this A and B are not allowed. The third one, AB star AA AB star, so it is going to fulfilling both the conditions. It will be having substrings on the left side as well as on the right side. So that is the correct option, C. Then next one is CFG, that is the context free grammar, very simple. Then next one, transition moves of PDA is decided by. Now, in the case of PDA how it is work? It requires current state, it requires input symbol, and it requires top of the stack symbol. So all are required for the PDA. Then next one, PDA is of how many tuples? So basically PDA is having 7 tuples. It is the wrong option. 4 tuples they are given. 7 tuples are there. So what are the tuples? Q summation Q naught A delta, whatever the tuples in finite state automata as it is will be there. And then we having Z naught, that is the Z naught as a top of the stack symbol, and tape symbol, stack symbol will be there. So 7 tuples are required in the case of PDA. That is the question number 49. Then question number 50, which of the following PDA is a non-deterministic? So both top-down PDA and bottom-up PDA, both are non-deterministic, because with respect to the given productions, they are going to change their behavior. So both top-down PDA and bottom-up PDA are non-deterministic. Then next one, which of the following statement is non-correct? They are talking about non-correct, means wrong. So every regular language is context-free language. Yes, fine. Union of two regular languages is a regular language. Yes, fine. Odd length palindrome is a context-free language. Yes, it is a wrong one. Odd length palindrome is a context-free language. It is a wrong one. Intersection of context-free language is a context-free language. Fine. So option number C is a wrong one. Which of the following is not context-free language? The first one is context-free language. Palindrome, yes, again it is a context-free language. End with BB, that is the example of regular language. So that C is not example of context-free language. Keep in mind the first two are example of context-free language, but the third example, which is not of context-free, it is a regular language. Which of the following tasks can Turing machine perform? Language recognition is possible. Compute partial function is also possible. So both A and B are the options or operations performed by Turing machine. And very last two questions: which of the following type of language can Turing machine recognize? Regular language is accepted by Turing machine. Context-free language is accepted by Turing machine. Non-context-free is also accepted by Turing machine. Means all types of languages are accepted by Turing machine. And last question is, Turing machine is of how many tuples? So they have mentioned here 7 tuples, but as per the university, it have 5 tuples. It have 5 tuples. So go with 5 tuples. 5 tuples will be the correct answer. So basically, these are the 55 questions given to the given in the question bank, that COVID time question bank. You can see here, which is from I think 2022, March 22 summer examination for automata theory, and these are the questions. So basically we have seen all the questions related to the MCQ. Now as per your requirement, we are going to discussing these questions. So basically I have I'll be share you one. Okay, so these are the, I think 60 questions are there. So a lot of the questions may be familiar with you. So shall we continue or take the break of 10 minutes and again start the another session? What do you think? What can do? Shall we take the break of 10 minutes and take the first 20 questions? I'll be take these questions. Total 30 questions are there. Sorry, 60 questions are there. In my mind, I'm going to take. Yes, I does not share you the screen. So shall we stop for 10 minutes and start the handwritten theoretical questions? Zamdar is saying that go continue. Yes, we can continue. Just wait. I'm going to attach a pen drive over here, which having the solution. Just wait for a moment. So my suggestion to you people is that this question bank is very, very important question bank. Definitely, whenever the questions will be asked, 14 mark MCQ will be there. Keep in mind. For the 14 marks, MCQ will be there. And most probably, whatever the questions we have shared, the MCQ form, that same question bank will be there. Probably 1 or 2 MCQ will be changed. Otherwise, the same MCQs will be there. Is it visible to you people? Is it visible to you? Whatever the screen I have shared, is it visible to you or not? No. Screen is not visible to you people. Once again, I am sharing the screen. Just wait, Zamdari. I am sharing the screen. Question bank, Adobe, Firefox, scan notes. Hello. Yes, is it visible? Whatever I have solved these questions, is it visible to you or not? At least say me yes or no. Yes, that's great. That's great. I'm coming back to the questions one by one. My plan is to complete all these 60 questions in 3 sessions. Once again, I'm telling you people, today I'm going to complete first 20 questions in the coming 2 hours, not more than 2 hours. Then on the tomorrow early morning, again, I'll be there for the next 20 questions. And finally, again in the afternoon session, as tomorrow is holiday, but no issue, I'll be give you time. So early morning from 7 to 9, first session, second session will be there. And again 10 to 12, third session will be there. So be ready for that, 60 questions. Yes. Just wait. Just wait for a moment. Okay, so the very first question you can see here. Explain direct method of proof with the help of example. So basically, what is meant by proof? You know that the statement which is convincing that it having correct answer. What they have given? A logical proportion of the statement that shows that it is true or false, or what they have given? A logical proportion of the statement that shows that it is true or false, or it is going to argue that it is a valid, then it is nothing but the proof. And there are two types of proofs. First one is the direct proof and second one is the indirect proof. So basically, direct in the case of direct proof, you can see here the proof by construction. So for example, proof by construction means what? Let us consider we have to find out multiplication of two odd number. So multiplication of two odd number will be definitely an odd number, and multiplication of two even number, again it will be a even number. So if you see here, multiplication of two odd number, multiplication of array, sorry. So multiplication, just wait, I want highlighter here. So if you see here, yes, that's it. Multiplication of two odd number is odd. So let us consider we have given two numbers a and b as a two odd numbers, and as it is an odd number, a will be written as a 2m plus 1. So 2 into some number plus 1, that will be the, because this 2m will be the even number. Again b will be equals to 2n plus 1, and c will be a cross b. So a cross will be, b will be what? 2m plus 1, 2n plus 1. So the result will be 4mn plus 2m plus 2n plus 1. So that is the result for that. And if you find out, or if you take the 2 as a common factor from these terms, then it will be twice of 2mn plus m plus n plus 1. So that one indicates, that one which is indicates it is an odd number. So that is nothing but the odd number. Multiplication of two odd number is the odd number. So that is the method by, screen is not visible. What can I do? Is it screen is visible, all of you? Is it visible to other? Please raise the hands, those who have screen. Just wait. Once again, I'm sharing to you people. Entire screen. Now tell me whether it is visible or not. Now tell me, guys. No. Just check whether it is visible or not. It should be visible, all of you, right now. Yes, that's it. Okay. So the very first question, what is the very first question? Explain the direct method of proof with the example. Explain direct method of proof with the example. Okay. So basically, in the case of method of proof, there are two methods. First one is the direct method and second one is the indirect method. So direct method is what? Proof by construction. So proof by construction is the direct method, and in this case, we have to prove this. For example, if two numbers are there, for example, two odd numbers are there, then by taking the multiplication of that two odd numbers, the resultant number should be odd numbers, or by taking the multiplication of two even numbers, the result should be even numbers. Okay. So if you see here, consider A and B are two odd numbers. So how can I write this odd number A? That is a 2m plus 1. This 2m plus 1 will be the first odd number, and 2n plus 1 will be the second odd number. Okay. So okay. So this 2m plus 1, that is the first odd number, 2n plus 1, that is the second odd number B. We have to take the multiplication of A and B. So what is the multiplication here? C is equals to A multiplies B. So finally, if you substitute here, A is equals to 2m plus 1 and B is equals to 2n plus 1. So it will be gives the multiplication as 4mn plus 2m plus 2n plus 1. So if you take the as a common term, twice of 2mn plus mn plus 1. That plus 1 indicates it is an odd number. Fine. That one represents the odd number. So we have proved here multiplication of two odd number is a odd number. Again, sum of two odd number is even. You can mention this also in the example. Also, you can mention multiplication of two even number is a even number, or sum of two even number as a even number. You can mention that things also. So these all are direct method of proof. So if question is asked in the university examination, most probably, then you can go with all this explanation. Now next question is what? Prove that root 2 is an irrational by using contradiction. So what we have to do, what is meant by contradiction? So in the case of contradiction, we are going to assume that the given problem statement is correct, and by solving that, it will be gives the opposite to that. So that is nothing but the contradiction. So if you see here, if you see here, so let us assume that root 2 is a rational number. So when number is said to be rational, so when it is going to represent in the form m by n, so root 2 will be represented in the form m by n. So basically, if you squaring on both sides this one, then it will gives you 2 is equals to m square plus n square. Again, by simplification, it will gives you twice of n square is equals to m square. Okay. Now we know that if m and n are two integers, then m square is a twice of n square. What it indicates? M square is a twice of n square. Okay, means what? M square is a twice of n square, so m square is a even. Okay, so if m is a even, now put m is equals to 2k. Yes, correct. Now put m is equals to 2k, and equation 1 will become twice of n square, which is equals to 4 times of k square. It will gives you n square is equals to twice of k square. Hence, k is also even. So n is also even, as both m and n are even. But if it is a contradiction, then m by n is equals to 2 is a irrational. Keep in mind this one. As both m and n are even, but it is contradiction, hence m by n is equals to root 2 is a irrational. Very simple. Don't worry about this. Consider this as a rational number. That is root 2 is equals to m by n. Rational means what? We can represent that in denominator and numerator format. So that root 2n is equals to m by n by taking squaring, by taking simplification. Then by substituting m is equals to 2k, it gives again that as a even number. Hence, it is not as per the definition. So it is an irrational number. Now question number 3. Explain about recursive definition on set. So what is meant by recursion? Whenever the given function is going to call repeatedly, then it is called as a recursion. So in the case of recursion, the very fantastic example of the recursion is finding the factorial. So this example, which is of finding the factorial, n factorial which is equals to 1, or n factorial is equals to n into n minus 1 factorial. So whenever n is equals to 0, you know that 0 factorial is equals to 1. And whenever n is greater than 0, we can go with this formula, n into n minus 1 factorial. So this is the example of recursion, because this term factorial will be repeatedly called. Here we define a factorial by any terms at n is equals to 0. Then by using n is equals to 0, find n is equals to 1, 2, 3 up to n. Again, the example for recursion, that is the principle of mathematical induction. So basically there are 3 principles of mathematical induction. That is 1 plus 2 plus 3 up to n, which is equals to n in bracket n plus 1. That is the first function, principle of mathematical induction. Then we can go for another one, that is 1 square plus 2 square up to n square. Also we can go for that 1 cube plus 2 cube up to n cube. So these all formulas you may mention in the this recursion, because they are repeatedly calling. You know that. So whenever n is equals to 0, it will be 0 in bracket 0 plus 1 by 2. Again, this will be used over here. You can see here plus 1. Okay. Likewise, the operations will be performed. Then Fibonacci function. Fibonacci function is also example of recursion. So in the case of Fibonacci series, two functions are given to you. That is f of 0 is equals to 1, f of 1 is equals to 1. And by using that, we can find out another function. So the standard formula is f of n plus 1, which is equals to f of n plus f of n minus 1. You can see here, f of n plus 1, which is equals to f of n plus f of n minus 1. So that is the standard formula. So by using the standard formula, either we can go with the top-down method or we can go with the bottom-up method. So whenever you are going for the top-down method, you know that what is meant by top-down method. So f of 4, which is equals to f of 3 plus f of 2. So as per the formula, what is our formula? F of n plus 1, which is equals to f of n plus f of n minus 1. So using that formula, we have written f of 4 is equals to f of 3 plus f of 2. But basically, we don't have the values of f of 3 and f of 2. So again, we are going to perform the operation on f of 3. So f of 3 will be what? F of 2 plus f of 1. And f of 2 will be what? F of 1 plus f of 0. As it now, it having the values of f of 1, values of f of 1 and f of 0. So we have to go for f of 2. So this f of 2 will be what? F of 1 plus f of 0, and this above 3 terms is written over there as it is. So 1 plus 1 plus 1 plus 1 plus 1, which is equals to 5. So that is the top-down approach or top-down method. And in the bottom-up approach, what we can do? We have given f of 0 is equals to 1, f of 1 is equals to 1. So using this f of 0 and f of 1, we can find out here f of 2. So f of 2 is equals to f of 1 plus f of 2, that is a 2. And f of 3 is equals to f of 2 plus f of 1. So already we have f of 1 with us. So we can write here 1. And f of 2 is equals to 2. So I can write here 2. So 2 plus 1 is equals to 3. Then again for finding f of 4, I'll be write down the formula. F of 4 is equals to f of 3 plus f of 2. So f of 3 we have find out which is as equals to 3, and previously we have also find out f of 2 is equals to 2. So the result is 5. So these are the methods of top down and bottom up parsing. Okay, so top down and bottom up approach. So whenever recursive definitions will be there, so recursion means what? Repeatedly calling. In that case, you have to write down the example of recursion: 0 plus 1 plus 2 up to n, which is equals to n in bracket n plus 1 divided by 2. Then 1 square plus 2 square up to n square, which is equals to n in bracket 2n plus 1 divided by whatever the formula you have. And whenever 1 cube plus 2 cube, the formula was n in bracket 2n plus 1 divided by, you have to write down 6, and then n cube, 1 cube plus 2 cube up to n cube, which is equals to n square in another bracket, n plus 1 bracket square divided by 4. So these are the three formulas for principle of mathematical induction. Then you have to go for Fibonacci series. In the case of Fibonacci series, top down approach and bottom up approach. So keep in mind from the first three questions, definitely. So what we have did, all these three questions are put in three sets. So definitely one questions will be there. So all these three questions you have to do perfectly. Fine. So that is the example of, again, recursion. Keep in mind. Fine. Again, this is the example of recursion. Now, write the regular expression for the following language. Write the regular expression for following language. So the set of strings of zeros and one with the odd number of ones. So that is the example, and that is the formula for this. So I'm not extending more time over here. So these are the answers you have to keep in mind. Question number 5, they have given very interesting questions. What is the regular expression and regular language? What is a regular expression for the following? So this question most probably may be asked for the university examination. So very first example, a string over a comma b with an even number of a's. With even number of a's. That is the first question. String over a comma b in infinite sequence. Then infinite sequence, what is that sequence? ABA, comma, a raised to 5, comma, ABA, a raised to 6, comma, a raised to 11, comma, AB, a raised to 13, a raised to 17, and so on. So that is the second regular expression. And the last one, the language of say identifiers. This is from book. The third example, which is from book, the first one and second one may not be familiar to you people. Now see here, regular language. A regular language over the alphabet summation is one that can be obtained. The screen is not visible. Now tell me whether screen is visible or not. Is it screen is visible to you? No. Now tell me whether it is visible or not. Is it visible? Yes, fine. Do one thing, Mronali, whenever the screen is not visible, please put me a message. Please put me a message on WhatsApp so that I can see on my mobile. Otherwise, what will be happen? We'll be go ahead and it will not be of our business. Okay, so please text me on a mobile. Fine. Now see here, talking about these regular languages, a regular language over the alphabet summation is one that can be obtained from these basic languages using operations, union, concatenation, and Kleene. A regular language can therefore be described by explicit formula. Now see here. So as I mentioned here, regular language which is going to perform union, concatenation, and Kleene operation. You know that. So basically, if you see here how to convert this, so these are the rules. Replace the set bracket, that is a curly bracket, by the simple parenthesis. Then this dot by union by plus. Okay. Then also comma by union and union by plus. This one is not correct. You should be replaced comma by plus or comma by union. Keep in mind. the result will be a regular expression. So what is the regular language? In curly braces 1 1 0 clean, and in another curly braces 0 comma 1 curly. So here will be what? 1 1 0 clean. Instead of this curly braces, we have mentioned here as a simple parenthesis. Again, instead of this comma, we have taken here as a plus and 0 1. So that is the regular expression of corresponding regular language. Simple, eh? The next one, the string over AB with an even number of A's. So that is the even number of A string. You can see here A. So whenever clean operation will not be performed, then it will be AA. Whenever the first B will be performed, then the string will be BAA and so on as per the requirement. Okay. That is very interesting question. I think most probably it will be asked for the tomorrow's examination. Keep in mind, all of you. So this is the question: string over A comma B in an infinite sequence. What they have given: ABA A raised to 5, ABA A raised to 6, comma A raised to 11, comma AB A raised to 13, A raised to 17. So that is the question given to you people. That is the question. ABA, comma A raised to 5, comma ABA A raised to 6, comma A raised to 11, AB A raised to 13, comma A raised to 17, and so on. So whatever the regular language is given to you, we have to convert this into regular expression. So what to do? You can see here this comma is replaced by plus. So you can see ABA is as it is, this comma is replaced by plus, then A raised to 5 as it is, then again this comma is replaced by plus, and so on, which is replaced by till the end. Fine, there should not be issue. Now you can see here ABA is as it is here, ABA, A raised to 5 as it is over here. This ABA concatenate with A raised to 6, you can see here. So rather than writing this substring separately, you can write this as a ABA raised to 7, AB A raised to 7, then A raised to 11 as it is, again AB A raised to 13 will be there, and A raised to 17, A raised to 17 will be as it is. So that is the substitution. Now what we are going to do, we are going to plan for separation of, you can see AB is taken over here, AB A raised to 7 is taken over here, then AB A raised to 13 is taken over here, and then whatever the terms, single terms, that is A raised to 5, A raised to 13, A raised to 11, A raised to 17, you can see here A raised to 5, A raised to 13, A raised to 11, sorry, not A raised to 13, A raised to 17 are taken. So these are the terms. Now what we do, we have take the common term as a ABA have taken as a common. So ABA into null will be nothing but the ABA into A raised to 6 will be AB A raised to 7, ABA raised to A raised to 12 will be AB A raised to 13, and this term you can find out here A raised to 5 as a common. A raised to 5 null will be A raised to 5, A raised to 5 A. So that will be the A raised to 17. So what is your observation? You can see here ABA plus A raised to 5, which having the common term, and here A raised to 6, A raised to 12 is there. Next term will be what? A raised to 18. Next term will be what? A raised to clean. So A raised to 6 raised to clean means what? Whenever it will be not visible. Is it visible? Brunali, please drop the message me. Is it visible or not? Yes, it is visible. Okay, fine. So if you see here ABA plus A raised to 5, and in another bracket null plus A raised to 6 plus A raised to 12 plus A raised to 18 plus as per the requirement. So for this term So for these terms, we will be write this one, a raised to 6 raised to Kleene. Okay, and for the first term, you can see here, for first time you can write here this as a ABA plus a raised to 5. ABA plus a raised to 5. Okay, so that is the question. Then language of C identifiers. So basically C identifiers which consist of digits, letters, underscores. So digits are from 0 to 9. Letters are from uppercase and lowercase. Lowercase from A to Z, uppercase from A to Z, and underscore. So all this combination will be nothing but the language of C identifier. So from these three questions, definitely my sixth sense saying that this question will be asked for the university examination, this one or this one. So be ready for this. Don't miss these questions. Now the question number 7, you can see here, give the equivalent regular expression for the each following. It's very simple. So what we have to do, these regular expressions are there. So we have to find out regular expression, regular languages are there. So this one will be replaced by simple curly braces. Okay, then 0 plus 1 will be replaced by 0 plus 1 star. Then 0 plus 1 will be here. You can see here 0 plus 1 star as it is will be there, and this 1 will be as it is over here. So that is the answer. Again 0 plus 1, 1 plus 0 star. Simply you can write this as a 1 plus 0 star, because this will be combined, 0 plus 1 or 1 plus 0. It doesn't matter. So that will be the correct answer. And in this case, what will happen? 0, comma 1 star, 0, comma 1 star will be combined together, and this one and this one will be there. Just wait for a moment, little bit wrong. Here 1 will be there. Sorry for this. Here 1 will be there. Will be 1. The next one, explain DFA with a extended transition function. So basically DFA, what is the definition of DFA? Q delta such a way that Q into summation tends to Q. That is the transition function. And whenever we having star, then it is called as an extended transition function. So when we are using extended transition function, so whenever we require to read more than one symbol, so at that time we are using the, or it is said as a extended transition function. Okay, so that is very simple. You can see here, this is the notation for extended transition function. That is delta cap of Q comma summation. That is a Q are in the state Q and read no input. We are still in the state Q. Okay, it's a very simple. You can see here. Then next question, define the finite state automata and design DFA for DFA for summation is equals to 0, 1 for the language that ends with 1, 1. For the language that ends with 1, 1. So basically, what is the definition of finite state automata? So finite state automata, which is a 5 tuples, Q summation Q naught A delta, Q summation Q naught A delta. So these are the 5 tuples I have mentioned here. Q summation Q naught A delta. You have to mention this in explain. So what is meant by Q? It is a finite set of states. Then summation is a finite input symbols. Then Q naught is the initial state. Then A is the accepting state, which is belongs to capital Q. It is the accepting state, and delta is the transition function. So you can see here accepting state, which is belongs to capital Q. It is the accepting state, and delta is the transition function. So you can see here delta such a way that Q into summation tends to Q. That is the transition function, and end with 1, 1. So you can see here end with 1, 1. So that is very important. 1, 1. So as it is end with 1, 1, it must require 1, 1 means 2 symbols are there. So 2 plus 1, which is equals to 3 states are necessary. So just wait for a moment. Screen चा काय प्रॉब्लेम आहे? I think now it is visible. Mronali, please put me the text message on my mobile, Mronali, if it is visible. May be, sir, due to network. I think so. Yes, yes. But we have to go ahead. There is no any option, Mronali, because only 4 days are remaining. Today is 9th. Tomorrow is 11th. Don't worry about that environment paper. You have to write that paper with your background knowledge, whatever you have studied up till your 12th. That is nothing but all environmental concept. You have to write all these things. Okay. Yes. So if you see a DFA for string end with 1 1. So 1 1 means two symbols are there. So 3 states Q0, Q1 and Q2 is given. Fine. Now end with 1 1. So as it is a DFA, it should having transition from both the input symbols 0 and 1. So if you give 0 over here, then it will be read 0 1 1. Yes, so both the transitions from Q0 with respect to the two alphabets 0 1 will be end. Again, from the Q1, if I give zero transitions over here, then what will be happen? It will be read 1 0 1. So which is not as per the definition, because it must be end with 1 1. So this should not containing the loop over here with respect to the 0. So this again check for 0 going to the Q2. So what will be happen? 1, again it will be read 0 and going to the accepting state. So again it is not allowed. So this 0 has to come back to the initial state, and that is the answer. Okay, so keep in mind this question is also very important. Question number 10. Define finite state automata and design deterministic finite state automata over the alphabet 0 1 for the language that ends with 1 1. You know that what 1 1. You know that what is the formal definition of finite state automata. I have given that definition in the notebook also. Okay. Then this is the result, and you have to draw the transition table. So that's all for the finite state automata. So whenever the question is there, you have to write all these things. Again, design a DFA corresponding to the regular language. That is a very interesting question. It is not visible again. Mronali. Is it problem to only Mronali or all the students? Is it visible screen? Screen is visible or not? Those students having screen visible, no. Okay. We all have same problem. Fine. No. Just wait. I am exit and again. Not no. Stop sharing. Just wait for a moment. I am sharing. Nobody should blame on me that you haven't shared the link. So that's why I have shared the link over here. Yes, is it visible, Aniket? Aniket, whether it is visible, Aniket, Subhan, Samarth. If it is visible, then tell me. Okay. Is it visible to you? Yes, that's great. That's great. Very good. Yes. So whenever you will be face the interrupting, please put me the message. We'll be resume again and again we'll be try. Because yes, fine. That's great. Okay, so that is the next question. Design DFA corresponding to the regular expression So you have to design the DFA. You know that what is meant by DFA. DFA means what? In the deterministic finite state automata, for the every alphabet, there should be a transition. Means as it containing two input symbols, it should having the transition from every states with respect to A and B. So if you see here is what A, B star, again what A, B star, and in between these two, we having the string ABA. Means what? ABA has to be read by this corresponding finite state automata. So for reading ABA, means three symbols are there. We require 1, 2, 3, and 4. 4 states are necessary. Yes. And in between that 4 state, I have written here A, B, A. In between that, I have written, you can see here, this A, this B, and this A. No issue about this. Now I have to complete the diagram. So Q0 having A transition which is goes to Q1, no issue. If I give this Q0's B transition to rather than this Q0, then what will be happen? It will be read other languages also. So I have to give here B over here. I have to give a loop with respect to B over here. Yes. So that will be fulfill this term B star. Again, shall I go this? Shall I give this A to the another? No, because it will be change the meaning. So A, B, B. This B and A will be fulfilling the condition this A, B star. And finally, self loop will be there and it will be gives you A, comma B. Very important question, keep in mind. You can pause the video and draw in notebook also. I am not going to share this PPT, absolutely, because I have seen that I have shared you lots of notes, which is written by me on your WhatsApp group. And unfortunately, you have given very low feedback for that notes. So I am not going to share these notes. Little bit, I am amazed with that feedback, how that notes will be the poor one. I don't have the idea, but might be those people given the feedback, they having the poor brain. That's why they have given. Okay, let it be. So that is the question, keep in mind. Yes. And after this, you have to draw this transition function, a transition table. Okay. Now the next question, what are the applications of finite state automata? Explain in detail. Guys and girls, keep in mind, these are the theoretical points. Okay. So as I am scrolling the screen, first of all, what you have to do while writing the applications of finite state automata, you have to write down definition, formal definition of finite state automata. That is finite state automata, which is a 5 tuple Q summation Q naught A delta. It has to be written by you people. And then you have to write all these things. So what is the first thing? Useful model for many important kinds of hardware and software, design of lexical analysis in typical compiler, that is a lexical analysis. Then software for designing and checking the behavior of the digital circuit protocols. Then next one, scanning large bodies of text, that is a web page recommendation, that is pattern recognition. Then in the case of protocols, communication protocol, you may go later on also. This is very simple. Then lexical analysis for compilers, already we have covered this one. Now tell me whether it is visible or not, Mrunali. Screen is visible? Okay, fine. So these are the applications, not more than this. These are the applications. Later on, you can see this recording also. Okay. So these are the applications applications you have to keep in mind: network protocol design, circuit design analysis, vending machine, DNA sequence analysis, AI in video games. So these are the things. That is the question number 12. Yes. Now see the next question. Explain NFA with the extended transition function. So basically that is the definition of NFA. That is what you have to do whenever the question is asked. Explain NFA with the extended transition function. So you have to write down what is meant by NFA. So NFA is nothing but non-deterministic finite state automata which containing 5 tuples. And with respect to the tuples, you have to write down delta, which is equals to q into summation tends to 2 raised to q. That is the NFA. Then extended transition function delta cap, which is nothing but q into summation star 2 raised to q. That is the extended transition function. Okay. And then you have to write down these things. So if you see here, yes, that is the question. Delta cap 0 1 0 1 0, delta cap q naught of epsilon, so which is from this basic diagram. So you can take any one of the diagram and explain these things. So if you see here, q naught's 0 transition, q naught's 0 transition which is goes to q naught, q naught's 1 transition which is goes to itself and q1, q1's 0 transition which is goes to q2, q1's 1 transition goes to q2, and q2's 0 transition goes to that particular, nothing is going to there. So that's why it is a 5 5. So that is the transition table with respect to the transition diagram. Now we have to work on extended transition function. So you can see here delta cap of q comma w. So q is the state and we having here w as a string has to be read. So delta cap of qx comma a, where this x and a is a subset of or substrings of this w. Keep in mind. Fine. So which will be given this formula, because we are going to perform this operation till p of k, p1, p2, p3 up to pk comma a. So that is union I is equals to 1 to k delta of p of I1. Here you have to keep in mind this one also. All these things you have to go through it and write down in your notebooks, because we having 3 days. You can write this for 1 or 2 times, then it will be easier to write in examination also. Fine. So that is the extended transition function. Yes, that is the example. You can see here, very interesting. Yes, delta cap of q naught 0 1 0. So you can write this as delta cap of q naught comma q1 comma 0. So which is given as delta of q naught 0 and union delta of q1 0. So this is the result, and which is from, don't be confused, which is from this table also. Yes, keep in mind this. Now explain NFA null with the extended transition function. The same question which is repeated. Previous was NFA for the extended transition function, and here is the NFA for null. So this, you have to take this null symbol over here and you have to perform the operation. So extended transition function delta in bracket q naught 0. So in this case, q naught 0 will gives the closure, as per the closure property, it will gives here q naught 0 means it will be goes to q naught, also it will be goes to q1 and q2 also. So finally you can see here it is going to q naught, q1, q2, because reading 0 it will be goes to itself. By reading this 0 and null, it will be goes to q1, having the same meaning as reading as a 0, and by reading this 0 null and null, it will be goes to q2. So that is the correct answer. Keep in mind, very simple and interesting things are these. Keep in mind, all of you. Then q naught comma 0 1, again q naught comma 0 1 means you have to perform 0 and 1. So it will be given this as, so perform this. Similarly, q naught of 2, go for this one. Fine. Now the next question, design a DFA for following languages. L is equals to x belongs to 0 comma 1 star, where x start with 0 and end with 1. So you can see here we are going to design this x start with 0 and end with 1. Okay. So very simple. Start with 0 we have taken, end with 1 also we have taken, and we have taken Q3 as a dead state. It is a dead state because it has to start with 0. So that's why there is a no any option for this one. So that one should be go to the dead state Q3. Fine. So that will become the portion. This is the dead portion. Whatever the transitions we have mentioned, this is the dead portion. So 0 transition will be goes to the next. Again 0 will be over here, as it has to be end with 1. So 1 will be here, and this 0 has to come back. There is no any issue with this 0 because by reading this 0 and 1, again it will be goes to the accepting state, and ultimately it is going to end with the 1 itself. So that is the question. Keep in mind, very important question. Dead state we have taken here as a Q3, and Q0 as the initial state, Q2 as a accepting state. Okay, and transition table is this one, Q0, Q1. So there is no worry about this. This one is the accepting state, this one is the initial state, and this is the dead state. I hope that you are getting these concepts one by one. I think so. Then question number, shall we go ahead or stop over here, all of you? What can do? Shall we continue or stop over here? If you bored, then we should be stopped. Okay, no issue. I'll be go ahead. Yes, continue. Fine. Please continue. Yes. Now, I'm just taking one screenshot, so there should not be any blame game that I haven't taken a lecture of you people. Also, I have put this on. Okay, fine. Close. Okay. Yes, going to this one. Convert the following. Question number 18. You can see here. Convert the following NFA with a null to the NFA. So now see here, one example is given to you. That is the example which we have taken in the our classroom. Okay, I haven't shared. Stop sharing. Now tell me whether I have shared this one or not, all of you. Enter screen. So, is it visible? Is it visible, girls, boys? Yes, fine. That's great. Okay. So convert the following NFA with a null to the NFA. So basically, NFA with a null, that is a non-deterministic finite state automata with a null transition, and that has to be converted into NFA. So keep in mind, we have given here one, that is A, B, C, and D. These are the 4 states with respect to the NFA with a null transition. Now, while converting this NFA with a null to the NFA, what we have to do? We have to first of all draw the transition table. So how many states are there? A, B, C, D. So write down this A, B, C, D as a 4 states. Yes, and where D is the accepting state. Then we have to mention here 3 input symbols. 0 is there, null is there. Yes, with respect to 0, with respect to this null, and with respect to this 1. So you can see here null, 0, 1. So if you take A as a null transition, so what is the A as a null transition? Just I am minimizing this so that it will be on single screen. No, it is not possible because they are from, no, not possible. Different pages are there. Yes. Okay. Okay, so these are the 4 states A, B, C, D, and these are the 3 input symbols along with null. That is a null, 0, 1. So what is a null transition of A? A is a null transition which is goes to B, no issue. Then what is the 0 transition of A? Yes, you can see here, zero transition of A, which is at itself, no issue. Then what is one transition of A? One transition of A is nothing going to anywhere else. So it is a phi. I think so there is no difficulty for you people. Then with respect to B, so with respect to B, you can see here, B's zero transition goes to C, one transition is phi, and null transition is D. So you can see here, B's null transition is going to D, B's zero transition goes to C, and one transition goes to phi. Then with respect to C, one transition going to B and nothing else. One transition going to B and nothing else, that is a phi. And with respect to D, there is no any kind of transition from मॅडम नमस्कार. एक 10 मिनिटात फोन करू. एक मी लाईव्ह लेक्चर मध्ये आहे, कंडक्ट करतोय. मी करतो फोन तुम्हाला. येस येस मॅम प्लीज. Okay, so that is a D. Okay, so with respect to D, phi is there. So that is the whatever I am going to highlighting this. That is the transition table for NFA with a null. Transition table for NFA with a null. So by using this transition table for NFA with a null, we have to draw the transition table for NFA. Transition table for NFA. So while drawing the transition table for NFA, you have to remove null. So we have taken here, you can see 0 and 1 over here only, not null transition is there. So A is zero transition. So if you see here, A is a zero transition. A is a zero transition, which is at A, no issue. Again, by reading this zero, by reading this null, it goes to B. By reading this null, by reading this zero, it goes to C. By reading this zero, by reading this null, it goes to D. Means what? By reading zero, A goes to A, B, C, D. That is very important. By reading 0, A goes to A, B, C, D. And by reading 1, A goes to phi. Because there is no any scope for 1. Okay. Then next one, with respect to B, you can see in the case of B, you can see zero transition which is going to the C, and nothing else is there. Just wait, I am removing this all highlightings. So with respect to this B, zero transition goes to C, and there is no further more transition either with respect to null 0 or 0 null or null 0 or 0 null. So B having zero transition goes to C. B is nothing having transition with 1. Again with respect to C, you can see here C having one transition. You can see here one transition of C from C to 1, that is going to B. One null going to D, that is BD. Fine. Yes. And then with respect to D, phi is there. I hope that there is no any difficulty to convert the given NFA with a null to the NFA table. Yes or no? Yes, na? Are you getting na what I am telling here? Are you vigilant na, or are you sleeping? Okay, fine. Yes. Okay, there is no issue. Now again, what we have to do, whatever the table we have drawn here, that table has to be converted into the NFA. So that is the result. You can see here. Yes, that is the table. So if you see, A is zero transition goes to A, B, C, D. So A is zero transition goes to A is 0 goes to B, A is 0 goes to C, and A is 0 goes to D. No issue. Fine. Then A is 1 goes to phi. So there is a nothing transition with respect to 1. So not necessary to mention this phi. Then B is zero transition, which is goes to C. Okay. Then C's one transition goes to BD. C's one transition goes to B and D. So that's all. Okay, so that is the transition diagram for NFA. Some people might be thinking about phi. Phi is only necessary or mandatory in deterministic finite state automata. Don't worry about phi in the case of NFA. Yes, only take the present states, that is the ABCD states you have to take over here. But if it is a DFA, then you have to take the phi. Okay, so that is the solution for the NFA. I hope that you got this question. Very important questions as per the tomorrow's point of view, examination point of view. Keep in mind this question. Don't be what we can say. Skip this question. There will be questions from this type. Now, what is the correction over here? Yes, anybody can suggest me what is the correction in this question? Yes or no? So if you see here, please pay the attention. If you see there, this question, whatever I am bubbling, by from initial state A, reading null, I am going to the accepting state. So whenever you are going to draw the NFA, this A will become accepting state also. Previously D was the accepting state, no issue, it will be remain as it is. Also you have to take this A as accepting state. So that is the correction in this question. Okay, हे लक्षात ठेवा. So this A will be the again accepting state. This A will be accepting state. This B will be accepting state. Are you getting now what I want to tell here? Because reading null transitions, you can see here, reading null transitions. Just a minute. Yes, reading null transitions. That is very important concept. Otherwise, this question will be totally wrong. It is none of business if you don't give A as a accepting state. You can see here, by reading this A, by reading this null, it is went to B. Again, by reading this null, it went to D. So that's why we can reach from A to the D, that is initial state to the accepting state with the help of null. So that's why this A will be become accepting state in the NFA. So that's why in this diagram, this A will be the accepting state as well as the previous accepting state will be remain as it is. So in the NFA, two accepting state will be there. Are you getting this or not? Those people get this concept, please give me the message, hi message or yes sir, or whatever the message, thumb message. Be fast, okay, boys and girls. Only one student got this idea. Subhan Sheikh, Aniket, Preeti. Okay, Jamdari, Pranay. Okay, fine, no issue. Yes, Samarth, no issue. Now the question number 20. So what is the question number 20? Convert the following NFA into the DA. That is the question you have given. This is the NFA. Because why it is NFA? Because zero transition from A having two states. Either it is going to the A or it is going to the B. So that's why it is a NFA. Now transition A is a zero transition. A is a zero transition which is goes to A. A is a zero transition which is goes to B. Fine. Then A is one transition goes to A is one transition goes to itself. Then B is a zero transition. Yes, screen is not visible. Just wait for a moment. I'm sharing the screen. Is it visible to you people? Screen? Okay, fine. It's visible. Okay, so you can see here A, fine. Then B is a zero transition, which is does not going to anywhere else, so it is fine. B is one transition goes to C. Then C is 0 and 1 doesn't going to anywhere else, so that is the transition table for NFA. Transition table for NFA. Up till now, I hope that there should not be any difficulty. Now, so as it containing three states A, B, C, 2 raised to n. So 2 raised to n means what? 8 states will be there, but it will be very hectic or it will be time consuming to draw all these 8 states. So what we can do? We have to start with the initial state, which was the initial state in the NFA, and as per the movements, we have to go ahead. So what was the initial state? A was the initial state. You can see here, A was the initial state. Previously, A was the previously initial state over there. So this one is A. Now A is a zero transition. A is a zero transition which is goes to AB. Not visible again. Just wait. Any difficulty, Monali, from your side? I think so that because I having very strong network connectivity. Please check your network connectivity. I'm again stopping and sharing the screen. But please check whether your network is you are in network or not. Now it is visible, all of you. Enter screen. It is visible to other. Okay, you can see the recorded one. Yes, it is visible. Aniket Pawar. Aniket, whether no sir. Gawale, yes sir. Pranav, whether it is visible or not, tell me about that only. Please put me the WhatsApp message. WhatsApp message. Anybody from your side? WhatsApp message. Tell me whether it is visible or not. Don't be chat on this platform. Now it is visible. Fine, good. Yes, thank you. Now see here. So, okay, fine. So now this is the NFA. Yes, this was the NFA. And we have drawn the table. We have drawn the table for this NFA. Yes, so that is the table for NFA. Okay. Yes. So that is the table for NFA. There should not be any difficulty. Now, by using this NFA table, we have to go for DFA. So what it gives, how to go, whatever the initial state present over there, you have to take that as the initial state. From this A, 0 went to AB. You can see here, 0 went to AB. Okay, by taking the 0 transition, you can went to the AB. By taking 1, you can go to the A. You can see here, A's 0 transition goes to A and B. That is the thing I would like to tell here. Then A's 1 transition goes to itself. That is the thing. Now already we have covered this state A. We got here new state A comma B together. So you have to take that state A comma B over here. So we have taken here A comma B. Yes. Now take 0 transition of A comma B. So what will be the 0 transition of A comma B? So you have to take here delta of A comma 0 union delta of B comma 0. So whenever delta of A comma 0 and B comma 0 will be taken by you people, so you can see here A comma 0 is this one and B comma 0 is this one. So AB union phi, this is nothing but AB. And then finally, delta of A comma B1, delta of A comma B1, that will be AC. You can see here AC, that is the union of AC. So that is the result. So if you observe here, so this one is covered, this state is covered, this state was initial state, and in the second line, you can say in this row, we got here new state as a AC. Fine. So we have to take the transition with respect to that AC. So we have taken here AC. Now take delta of AC comma 0, delta of AC, okay, comma, it is out of box, comma 0. Okay, so delta of AC comma 0, which will gives you AC, you can see here, that is AB union phi, that is AB. And delta of AC comma 1, that will be A phi, that will be A. A phi means it will be gives you A. So that is the transition table. So that is the transition table for what? That is the transition table for your, yes. So that is the transition table for DFA. And finally, you can draw here a simple DFA. So that is the initial state A. A is one transition. You can see here, A is one transition, goes to itself. A is zero transition, goes to AB together. Then AB is a zero transition, which is at itself. AB is one transition, which is goes to here AC. Then AC is a zero transition, which is goes to AB, and AC is one transition, which is goes to A. So that's all. That is the DFA. So whatever the two problems, see guys and girls, whatever the two problems, this problem and all these problems, whatever I am discussing, it is very important. It will be definitely in your tomorrow's paper. Keep in mind all these things you have to write. As I am presenting here, you can play that video later on as per your requirement, and you have to solve all these things. Okay. Don't think about the things which is not familiar to you. First of all, focusing on the things which is very familiar to you, or you can get out of marks over there. So this is very important question. This is also, that is 16th, 18th and 20th number question is very important. Okay. Then question number 21. So given NFA, so you have given one NFA. So what is that NFA? So this is the NFA. So what it contains? 4 states: Q0, Q1, P1 and P2. Sorry, P0 and P1. Q0, Q1, P0 and P1. These are the 4 states. Yes. And some transitions are given to you. And you have to find out here extended transition function, that is a delta star over the state Q0 having the input string 0101, and you have to find out the result. So Q0, if we go through 0101, then what will be happen? 0, it will be read 0 going to the Q1. Again, it will be read 1 going to the Q1. Here is a null. We can read this null going to the P0. Again, this 0 will be read going to the itself. And again, this 1 will be read. It will be going to the P1. So that is the extended transition function. In the university question paper, they have given 101 string. And if you take 101, it will not going to the accepting state. So that's why I have corrected this as a 0, 1, 0, 0, 1, 0, 1. So it will be going to the accepting state. So it will be work as 0, 1, null, 0, 1. Fine. So by reading this, it will be going to the final state. This one and this one having the same meaning. It's a very simple question number 21. Now see question number 22. Very interesting question. It will be asked for your tomorrow's examination. State and prove the Kleene's theorem part 1. So what is the Kleene's theorem 1? Every regular language is accepted by finite state automata. You can see here. A regular language can be accepted by finite state automata. That is the Kleene's theorem 1. And basically Kleene's theorem, which consists of 3 subparts. First one is the union, second one is the concatenation, and third one is the Kleene operation. So on the basis of union, concatenation, and Kleene, Kleene theorem 1 is working on. So you can see here, if a language accepted by finite state automata, then it will be also accepted by NFA with a null transition. Okay, what they are going to say? If the language is accepted by finite state automata, you have to mention that that language is accepted by NFA with a null. Again, you have to mention that if the language is accepted by NFA with a null, then it has to be accepted by NFA transition. And again, you can say that if it is accepted by NFA, then definitely it is accepted by finite state automata. So these are the 3 statements you have to mention over here. and then later on we have to looking for union, concatenation and Kleene operations. So you can see here it will contain the operation like union, concatenation and Kleene. Fine. If L1 and L2 these are the two language, then by induction hypothesis we get L1 union L2, L1 concatenate L2 and L1 star as an operation. As I mentioned earlier, if two languages are there, L1 and L2, then you can perform the operation union, that is the L1 union L2. You can perform the operation L1 concatenate L2 and you can perform the operation L1 Kleene. So these are the three possible operations in the case of Kleene's theorem 1. Now, what we are going to do? So let us consider M1 and M2. These are the two finite state automatas. Okay, and it having the tuples Q of I, summation small q of I, A of I, and delta of I. So that I will be mentioning 1, 2 as per the requirements. Means M1 will be equals to Q1 summation small q1 A1 delta 1, and M2 will be equals to Q2 summation small q2 A2 delta 2. So these are the things. Fine. So now see here. This is the symbol for union. Then this is the symbol for concatenation. And this is the symbol for Kleene operation. These are the three Kleene operations. Here, what we are going to do in the union. In the case of union, if let us consider M1 and M2, these are the two regular language, two finite state automatas. Then MU will be what? QU summation QU AU SU AU delta U. Fine. Here QU is equals to Q1 union Q2 union small q. So new initial state we are going to adding over here. QU is accepted by either Q1 or Q2. QU is accepted by either Q1 or Q2. AU is what? Accepting state will be what? All the accepting state from first finite state automata, union all the accepting state from second finite state automata. Okay, and delta U is equals to QU comma null, which is equals to Q1 comma Q2. So this is the thing. So let us consider this is the scope of first finite state automata, which containing already I have given this Q1 as the initial state from the first finite state automata, and F1 and F2 these are the accepting state from the first finite state automata. Second finite state automata, this is the scope of second finite state automata, and before these two finite state automata we have added new initial state QU and given null transition from QU to Q1 and QU to Q2. So that is the resultant for union. Very simple. Already I have given in this notebook also. That will be asked for tomorrow's examination, either Kleene's theorem 1 or Kleene's theorem 2. Okay. So that is the question which is asked many more times. That is Kleene's theorem 1. So whenever you have to write down union, you have to go for this diagram. Before drawing these diagrams, you have to draw these two automata separately and then add this new initial state by giving null transition to the previous initial states. Then next one, concatenation. You can see concatenation MC is equals to QC summation small qc AC delta C. So that is the result over here. So no need to add the new state. So in this case, no need to add the new state. Whatever the initial state of the first finite state automata, that is a Q1 will become here. Q1 will become here. New initial state in the concatenated result. Okay. Then accepting state will be what? Accepting state from the second automata will be accepting state, and accepting state from the first finite state automata will become the normal states. So that's why we have mentioned AC is equals to A2. You can see here A2 is equals to AC, that is the accepting state. Keep in mind the accepting state from the first finite state automata will become the normal states. Then what is the MC? MC is equals to M1 concatenate M2. Means initially you will be read the first finite state automata, then it will be read the second finite state automata. It means that M1 concatenate M2, which is not same as M2 concatenate M1. They having different meaning. Fine. So QC is equals to Q1 union Q2. So whatever the states present in first finite state automata and second finite state automata, we have to combine that together. And delta C is equals to delta C F1 or F1 comma null which is equals to Q2. And that is the result. So keep in mind, this is the scope of first finite state automata. This is the scope of second finite state automata. We have converted the first automata's initial state into the accepting state of the resultant. This state become, you can see here, this state is it visible now? Now is it visible, all of you? Yes or no, Brunali? Yes, it's visible. Okay. So these are the two scopes. So this one become the initial state from the concatenated finite state automata. This one will become initial state. Then the final state from the first automata will become normal state, you can see here. Then you have to give null transition from first finite state automata's final state to the second automata's initial state. You can see here. Here is the null, here is the null, and second automata's final state will become as it is. So that is nothing but the concatenation. This diagram is very important. Keep in mind. And keep in mind that you have to draw that diagram separately. Initially, you have to draw the, what we can say, this diagram at the very top level, top page, then draw this one and then concatenate this together. And the last one, Kleene's theorem. So in the case of Kleene, you can see here, mk is equals to qk summation small qk ak delta k. Okay. So qk is the new state not in q1. Qk is equals to q1 union small qk. Ak is equals to qk. Okay. Qk is the initial state. Qk is belongs to capital Qk. Delta k of af comma null, which is equals to qk ak, and delta k of ak null is equals to this q naught. Now see here, let us consider this is the finite state automata given to you, and you have to perform Kleene operation over here. Very simple. What we are going to do, see here. So this is the initial state. Before this initial state, we have added here qk. That is the new initial state. And that new initial state is nothing but the accepting state. Both the initial state and accepting state in case of Kleene are same. That is qk is equals to ak. Okay. Then give null transition to the previously initial state. So this is the new initial state. We have given null transition to the q naught. That is the previous initial state. Then whatever the previous accepting state, A was the previous accepting state, this will become normal, and from that state we have to give transition towards the new accepting state with null. So that is the Kleene closure, or that is the Kleene one. Okay, so whenever the question will be asked in the Shivaji University Kolhapur, state and prove the Kleene's theorem 1, you have to draw accordingly. What is meant by union, what is meant by concatenation, and what is meant by Kleene. Fine. I think so that there is no any difficulty from your side. Shall we go ahead or stop over here? Shall we go ahead or stop over here? All of you, tell me. Shall we go ahead or stop over here? Because already we have completed 20 questions. Only 40 questions are remaining. Shall we take it on? Yes, continue. Yes, no issue. We can go up to 30 questions. And tomorrow one session will be go for another 30 questions. So now see. Okay, fine. Now see the next question. Kleene's theorem second. So what the Kleene's theorem second states? So in the case of Kleene's theorem 1, what it was? Every regular language was accepted by finite state automata. And what Kleene's theorem second states? If the language is accepted by finite state automata, then it is a regular language. If the language is accepted by finite state automata, then it is a regular language. Now you can see here m is equals to q summation q naught a delta. That is the finite state automata. That is the finite state automata given to you. If we consider p and q as two states, then try by using mathematical induction, we can take union of which is a regular. Means what we are going to do? We are going to take here two states p and q, and by using principle of mathematical induction, we can try to show that it is a regular one. So that is the one thing. If p is initial state, then the transition from p to q should going from p to q in k states. So what we are going to assume here, p is the initial state, q is the another states, and I have to traverse from p to q. Then in between p to q, there are k states. Okay, so k is the large enough. K means if number of states are there in between p and q, then L of pq will be large enough. Fine. Then next one, let us consider n states in the form 1 to n and path going through S. Let us consider n state in the form 1 to n and path going through S. Now consider the string xyz. Now consider the string xyz and x is equals to yz. Then we can write here delta star of p comma y is equals to s, delta star of s comma z is equals to a. So you can see here delta of p comma y is equals to s and delta of s comma z is equals to a. Screen is not visible. Just wait. Is it visible? Now tell me, is it visible or not? Yes, fine. See here. Okay. So after taking p and q as the two states, for example, p is the initial state and q is the states where we have to reach. Then while reaching from p to q, we require k stages. Then if k is too much longer, then you can mention here L of pq. Yes, so that is the thing we have discussed here. Now see here L of PAN. So again what we are going to do, again we are going to take here L of PQ for n states, then L of PAN is equals to L of PQ. So we are going to take here AN, which is the state, n is the not higher, that is number of states higher than n. N is little bit states, number of states, which is lesser than q, sorry, and greater than p. So that is the assumption should be over here. L of PA in n is a regular, then L of PAJ is also regular if 0 is less than or equals to j, less than or equals to n. Means what we are going to try here, if P of A comma n is a regular, then L of PAJ is also regular, where j is less than or equals to n. So the meaning of this statement is very important. What we can say, if j is less than or equals to n and greater than or equals to 0, and if L of PAN is a regular, then L of PAJ is also regular. That is the thing. So L of PAN is equals to L of PAJ. So that is the regular. Is it visible? Okay. So likewise, again, what we can say, by the principle of mathematical induction, yes, by the principle of mathematical induction, Basically what we are going to do, we are going to take one state that is called as a basis state, and that is nothing but, you can see, while proving the basis state, L of PQ0 should be regular. So this 0 is nothing but the basis state. Okay, that is the state does not contain more than 0 states, that is it contain only one symbol, that is finite. So PQ0 is a regular. What we have did, we have taken basis state, and the basis state is nothing but the state which having a 0 states. So definitely if a 0 states are there in between P and Q, definitely it is a regular. Okay, then again we are going for the hypothesis. So in the case of hypothesis, instead of 0 will be, we have to take here k states. We have to take here k states. So as per the definition of principal mathematical induction, P comma Q comma K is a definitely regular. And again, as per the principle of mathematical state induction, induction hypothesis, P comma Q comma K plus 1 is also regular. Okay, so hence for 0, K and K plus 1, it is a regular. And so finally you can mention that if it is regular for 0, if it is a regular for 1, if it is a regular for K, and if it is a regular for K plus 1, hence it is a regular. So you can see here, P and Q, these are the two states, and in between K plus states are there. So that is the meaning. So it is valid for 0, it is valid for K, and it is valid for K plus 1. That's all. Very simple. This one is very simple. Yes, so we have completed almost 20 questions. So whenever we will be coming to the tomorrow's session, we'll be completing whole syllabus. Okay, and my one suggestion to you people, that the things which is not grabbed by you people, please leave that things. Don't think about that things. Otherwise, what will be happen? It will be very difficult to you people, that nothing will be grabbed by you, and very difficult at the time of examination. I think this is the pumping lemma. Okay, fine. Pumping lemma for CFL. Yes. So I'll be explaining all these things on tomorrow. Thank you so much for your patience listening. So right now 47 students are there, and I'm going to give only permission to the subscribers, because voluntarily I'm taking these things, and I'm not taking a single rupees from you people, and I does not necessary also. But those who are subscribers, they'll be take the benefit of this only. Those who are not subscriber, I will not be think about them, because I'm spending my time after 4 p.m. Thank you so much. We'll be see you tomorrow.